Every solar panel begins as ordinary sand, silicon dioxide pulled from the earth. This raw quartz, purified to 99.5%, is the foundation of every photovoltaic cell. Inside a submerged arc furnace, quartz reacts with carbon at 1500 degrees Celsius. The oxygen burns away, leaving behind crude metallurgical-grade silicon. Inside CMOS reactors, chemical vapor deposition builds ultra-pure silicon onto seed rods. The result is polysilicon, 9 pure, the cleanest form of silicon on Earth. A seed crystal is drawn upward from molten silicon at precisely 4,414 degrees. Atom by atom, a single crystal silicon ingot, called a boule, forms in perfect alignment. A multi-wire diamond saw slices the bowl into wafers just 180 micrometers thick. One ingot yields over 1,000 individual silicon wafers. Wafers are etched in alkaline solution, creating microscopic pyramids across their surface. This texture traps incoming light, cutting reflection losses to less than 5%. At 850 degrees, phosphorus gas diffuses into the wafer's surface, just 300 nanometers deep. This creates the PN junction, the electrical heart of every solar cell. A plasma reactor deposits a silicon nitride layer just 75 nanometers thick. This anti-reflection coating gives solar cells their characteristic deep blue color. Silver paste is pressed through a fine mesh stencil, printing electrical contacts directly onto the cell. These microscopic finger lines will carry current from the cell to the circuit. The wafers pass through an infrared firing furnace, peaking at 860 degrees Celsius. Silver contacts fuse permanently to the silicon. The cell is now electrically complete. A calibrated solar simulator fires a precise light pulse, measuring each cell's electrical output. Every cell is sorted by efficiency class, ensuring consistent panel performance. Copper ribbon connects each cell to the next using infrared soldering, building a string. 12 cells in series multiply voltage, forming the panel's core electrical structure. Cell strings are layered between glass and backsheet, with EVA encapsulant film between each layer. A vacuum laminator seals the entire stack at 150 degrees, bonding it into a single weatherproof unit. An anodized aluminum frame is pressed onto all 4 edges and sealed with silicone. A weatherproof junction box, with bypass diodes, is bonded to the rear surface. Every finished panel is flash tested for its exact power output, then imaged with an infrared camera. Electroluminescence reveals any hidden microcracks or defects invisible to the naked eye. From a grain of sand to a 400-watt panel, a precision instrument that converts sunlight directly into electricity. This is the technology remaking how the world is powered. Subscribe for more factory processes.